Right, this is going to be a tutorial on how to use Fusion 360 to make toolpaths, and a little bit also on how to run the CNC. It's probably going to be a pretty long video. I'm planning on trying to go through everything that I've learned and over my 3 years of doing it. So, yeah, there's lots of stuff to talk about. Lots of little tips and tricks, and also, it's never complete. I'm always learning more things, so hopefully you continue making the process more efficient and refining it. So let's jump in. So to get started, well, the first thing you're going to need to do is get a part. So we use Onshape for all of our actual CADing, even though Fusion 360 is also a CAD platform. So what that means is you're going to have to import any part you want to cut on the CNC from Onshape. So right now I have an Onshape document open that has some personal meaning to me, because this is actually some of the first pieces I CNC'd. So this was the 2022 robots drivetrain, tank drive, not swerve yet. Anyways, I'm gonna show you how to to start, there's multiple ways to import parts, and they have their own advantages. So I'm going to show you the way that I started importing parts and what's better for 3D geometry, which is when you have any pockets that are certain depths. This is the way that I would go with, but more recently I've been for 2D geometry. If you just have some bracket like this, you can just select the 2D geometry and then extrude it in Fusion 360, and that will actually have a bunch of advantages in Fusion 360 and make the process faster. But I'm going to start with the 3D geometry, and this is when, let me show you an example of a piece I'm talking about. So this is one of the first pieces. I actually messed it up. I did not see the 3D geometry when I made it. I remember that pretty vividly, but it's all right. That robot turned out fine. So I'm just going to isolate it in Onshape. So what I'm talking about is like this. There's some depth. So you're going to have to export the whole 3D object, because if I just selected the 2D face, when I extruded it, it would not have this depth in it. So here. So I have it selected, and currently I'm in assembly, and that's fine for exporting it like this. So I'm going to hit export, and the type that I want it to export is going to be IGIS. I think step files also work, but IGIS is what I've always done. So, and that's it. It's just IGIS. There's no units here, so you can just export, and it'll export to the computer. So now I'm going to make my way over to Fusion 360. Okay, so I'm already logged in here, but you're going to have to create an account. Students have accounts for free. You're going to have to probably put a picture of your student ID when you make an account, and then you'll have it for a year, which is great. So make sure you have an account, and then you can download it on your computer at home and do this all at home also to make stuff go faster. But I'm already logged in here, and this is the screen that you'll see. You'll be shared to the team account, so there's this with a bunch of folders, but I'll just do it in Robots 2024. So when you have exported the part, you can upload it, select files from the computer, and here we go. And then the screen over here. Then we just hit upload. And this, sometimes it takes a while to upload, and I've had it before when it just feels completely stuck, and I've had to reload Fusion 360, just close it. I'm not exactly sure, but that's especially when I try to upload multiple parts at once, so maybe you just should stick with doing one part. But most of the times it works fine. All right, and I have a part here. Okay. So if I was going to do multiple parts, I would have to upload them each individually, and they would come in different files, and then I would have to copy it over. So I'll go and copy another piece over. There's one piece that I think will be helpful for something later, so let me see if I can find it. But here, I think these here. Let me quickly get to the right page. Okay, so this is the piece that I want. I'm gonna copy, and you can just come here and there's this paste new, and now both pieces are in here. And now you see these different arrows, and this is how you want to orient it. So once you export everything in, you want to orient them together, both to save material, and then also you don't, it's not necessary to, but I think it's really important to make sure they're on the same level, the Z height. That will help us debug things. So actually, there's something I forgot. The first thing you probably want to do when you once you export it in or import it in, is the units. It's always on meters for me. I have inches set as default, but it's always on meters. So if somebody figures out how to change that, that'll be nice. But I just always change it so you can use the units that you're probably most familiar with. Anyway, so because I'm going to try to make them on the same Z height, you see, I can like drag this around. So I should also need to adjust the other dimensions, but the Z height is the biggest thing because we're going to be cutting them all on some plane. So I'm going to move this piece over, but I don't know how much I need to move it over. So I'm just going to do a quick measurement. So I just hit the inspect tool up here, and I can just get this quick measurement. That's the distance apart, and you can just copy it. Maybe not. Maybe you can't copy it. Okay, well, I can remember that number, 8.486. So now I can select this piece, and I would suggest, so sometimes if you select a face and then hit move, is the move thing, you actually start moving the face just like that. Because when you import it in, this is the reason why this is not the best way to import it, because when you import it in like this, it's just a bunch of different faces all stitched together. So then you can move stuff, you can like destroy the piece. So you don't want to do that. You want to select the whole piece by selecting the bar, and then you can hit M for move, or also in modify, there's move and copy. But if you just hit M, that's the quickest way to do it. Oh, I deselected the piece. And now I probably forgot my number, but let's see. We want to move it down, negative 8.486. Nope, 8 point. 8 point. Ooh, now I have another. Okay, fun start. Let's figure this out. 0.331 up. So that's how much we're gonna have to move it up. So I can do that quickly. 0.331. Okay, so now they're on the same plane, but now we want to actually orient it. So I'm not going to worry too much about material. What you're probably going to do is you're going to have a material you're going to cut to the right width, and then you're going to have to arrange it based on the material you have. We're not actually going to cut this out, so we're going to just arrange it like this. That's fine. Okay, so we have two pieces. You definitely don't, when placing them together, you need to leave enough space for the actual end mill to go and cut. So probably 1/8 of an inch, and you can just do a little extra. It doesn't harm you. So both of these pieces have 3D geometry, or I don't know, 2.5D. It's fun because our CNC is 2.5D because it cuts depth, but it doesn't really cut like complicated 3D geometry. So these are both 3D 2.5D parts. And you want to make sure that the features are all on the same side, like not this, so this piece is not upside down. So you can cut everything relative to just on the same face. And then something that maybe I should start talking about before is just navigating Onshape. I mean, you learn it, but I'm using a mouse. I really encourage you to use a mouse. Trying to use the trackpad you will not be very successful. To drag the screen around, I'm just clicking on the scroll button of the mouse, and then to change the angle, you do shift and scroll. So this is a little different from Onshape, which is a little annoying, and you might be able to change it in preferences, but I've just gotten used to it and it's fine. Okay, so we have our two pieces. They're oriented together, right face up, and they're on the same level, which will help make sure that we don't make mistakes later on. So I'm going to leave this here for now, and I'm going to go show you the other way to import parts. Okay, so let's pick a different part. Why not pick street sweepers? Such a cool little mechanism, eh? Okay, so let's say we want to cut out whatever, these three parts or something like that. So you can see here I'm actually in assembly. So this is the main assembly for the street sweepers, and that's probably where you're first going to go to try to find the parts. But then from here, you actually can't, so you can't export the 2D geometry from the assembly, so you have to go to the part studio. So if you click the part and then right click, you'll see the switch to street sweepers, and that's just the name of the part studio, street sweepers. So if we switch to here, I believe it will highlight the part. Great. And let's say these are the three. I think those might be the three parts we want to cut anyway. So if you want to cut this one, and this one, that's good. So how you do it is you'll select the face now. This is the 2D geometry. So this is the face we want to cut. And then instead of doing export, you want to do export as a DXF or DWG. So we're going to export as a DXF. That's the file type that Fusion 360 takes, and it is, nothing. That's just the file you have to use, and it's going to be it's a 2D sketch. So you'll see that later on, but let's upload it now, and that's a file name, download. Great. Sometimes it can be download or store file in tab, which will just actually download it to the Onshape instead of downloading to your computer. So you want to make sure it's download. So there, it's download, and then we'll just go through all of them and do that quickly. Okay, so now we download all those DXFs, and now we're going to go back to Fusion 360. So on Fusion 360, to import a DXF, you're going to actually want to be in a file. So to make a file, you can just go here, new design, and that'll make a file. When you load it up, oh, I thought that was a new design. Nope. Because I didn't actually load it up now. When you load it up, it will actually open a new template that's just untitled, and you can just load it in there if you're just starting. So to insert it in, go to insert DXF, and then you'll have to select a plane, and then you want to select the file from your computer. So select file from computer, and you only can do one at each like import, unfortunately. So it's gonna be a little bit slow, but in the end, I think it saves time. So this is gonna be somewhere. There it is. So this is a 2D sketch right there, and I don't need to move it around. That's fine. And let me. So actually, this is the thing. So when you create your own document, it actually will use your preference. That's why it's in inches. But if you don't, I guess it might just use meters, whatever. So there's one part right there, and then let's insert another one. Select the plane. Open, and they take a little bit to load, and then once that screen pops up, it means it loads somewhere. So there it is. This is right by the origin. Nice, and we have one more to do. All right, select, and our last one. Okay, so let that load. And I'm going to drag it because they're on top of each other. Probably not best, so just drag it over, and that's fine. Okay, so now I have my three 2D sketches, and now to get it to be 3D again, we're just going to have to extrude it. So the whole reason that we're doing it, we're exporting it as a 2D sketch and then extruding again, is because we want them to be able to be components. So that will help us both when we're selecting geometry later on, and then also to like arrange them how we want to. So it's really helpful for them to be components. So here we do that. We have to select the distance. So whatever the distance is, I know that this is going to be a 1/4 inch. So 0.25 is good. And then I'm going to select new component. And I think I actually have to do body here. I think if you select component, they'll all be the same component. I can just try. Let me see. Yeah, see, they're just one component. So actually, what you want to do, so you can edit it down at this toolbar here. Oh no, sorry, that's not this here. New body. That's better. Wait. Delete. Wait. Let me see if I delete this. I'll just go. So it just turned off our sketches. It hid them, but we can go back. Let's do this again. So yeah. So you want to. I'll show you how to make them a component. So you want to first do this, and you want to extrude them actually as a body. So new body, that's good. And that's the same thing as the pieces we have. Oh, not there. Now I'm just going all over the place. Right here. These are bodies. You can create them components, but then they like still are all the different faces, so it just doesn't really work out. At least I have not found a good way to make it work out. So now we can hide the sketches again. We don't need those anymore. And we have these bodies, so you open up the bodies, and now we have each body, and we can just select. I'm just hitting Control or Command because I'm on Mac, but same thing. And then there's create component from body. So now we have 3 components, great. And let's say we want 2 of each of these. You can just hit Control C, Control V, and just enter them in. And I'm not even going to worry about placement because I know I'm about to do another arrange, and I'll show how that's done, and it will do the placement for me. So before, imagine we have like 10 parts, we all have to drag them and fit them together, and it's not going to be optimized, right? We're going to lose some material, whatever. So that's the problem with the other method. But now, because they're components, we can actually use this feature called arrange. And basically what you do with the arrange is you have to fill in a couple of things, but then it will arrange the pieces for you, and you can set like the distance apart. So here, select components. So you can just go down the list, select all the components you need. And then there's also this box, create copies. Don't uncheck it because you don't want to create copies of these. You want to just select them all. So don't create copies. And then it says select a plane you want to do it on. And then it asks for some dimensions, and this is the dimensions of our table. Well, actually, no, this is not the dimension of the table. Our table that we cut on is 18 inches, but actually goes to like 31 inches. I think it's like 31 and a half. But this is usually because we get most of our stock in 2 by 4 feet, so we usually cut it down into along the 2-inch, not 2-foot side, along the 2-foot side into 18-inch chunks. That's why it's 24. So usually if you want to try to fit it in, you can fit it in here. Now we have much less, so you can see it, or put them all in a nice line, which is nice. But imagine if we had a smaller piece, we're trying to save material, we're using some old material. This is only like 6 inches maybe by 8 inches. It's probably enough. Yeah, see, it can fit them all in that still, and it does all the organization for you. So what is that? So that is, so we select the face, plane, and we've set the size here, and then there can be an offset, and this is the offset from the side. So imagine if I wanted it to not be right up to this side right here. If I want like 0.125, let's say an 1/8 inch of space. Oh, I'm just gonna go back and edit that. 0.125, and then here 0.125, and then placement, clearance, and I believe spacing. Okay, this is the other thing. So that offsets it from the side, which is nice. And then there's the spacing, which is how far apart they are. So most of our end mills are going to be either 4mm or 1/8 inch. I think we mostly have an 1/8 inch now, but it might change in the future. Whatever it is, just make sure there's enough spacing. And now that we have plenty of space, so let's just keep it generous. 1/4 inch, or you can even do more, but that's enough. You just need at least an 1/8 inch because that's the diameter of the bit. And then So, oh, that's the frame width. So that's already adding some frame. So I don't, the offset, oh, the offset's from the plane. Oh, okay, the offset wasn't necessary. I thought that was talking about the frame width. So the frame width is how much space from the side. Also, this is not the stock you're going to end up with, so it doesn't really matter. But the object spacing is what really matters. So right here I have 0.197, which is like almost like it's more than 3/16, a little less than 5 millimeters. So it would be plenty for both. Because we have so much extra space, you can always just do like 0.25. Oh, messed that up. And is this still loading? Okay, well, it changed it a little bit, but then now there's even more space, so that's fine. So now we've loaded stuff in both different ways. You've seen how to use the range, which is only really possible, at least I think I've been able to do it with the other, when you import through IGES with the 3D geometry, but it's best when you just, it's cleanest and easiest when you just do the DXF, 2D geometry, and extrude it, as long as there's no three-dimensional features that you're going to miss. So I'm going to go ahead with this one and show you how to make the toolpaths now. So we were in design here. There's this drop down here, and the two tabs you use are design and manufacturing. So now we're going to go to manufacturing. You see a little example of a toolpath. That's nice. So first thing to do is always change the unit. Right now this is inches because this is my document, but sometimes it will be in millimeters or meters, so you're going to want to change that. Yeah, so okay. So the first thing you want to do when you get into here, okay, other than changing the units, is the setup. So this is, the setup is the stock that you're going to cut. So you just hit the setup button up here, the folder, and basically we're going to tell the computer where our material that we're going to cut is going to be, how big it is, and basic dimensions of that, and where it's, not necessarily where it's going to be on the table because you zero it on the table later, but just where it is, where the edges are relative to the pieces you have here. The only thing that really matters is that this piece is not bigger than the piece you're actually going to cut it out of, and all the pieces are enclosed, right? It's fine if we have a 24-inch by 24-inch piece and we'll just kind of this little thing out. You don't have to make this 24 inches by 24 inches. It's fine that it's only 6 by 8 inches. Okay, so the first, and then also we need select the axes. So these are basically, we're setting up a coordinate plane, so we're going to say where our origin is and what direction which direction the X and Y and Z or Z axis, if you want, are pointing. So here you can, this is the model orientation, which is the same as that, but we can change it. So let's say we want, so I think it's easiest to select X, Y. Sometimes it doesn't really work because of the geometry. Like for this piece, imagine if none of these could be an X and Y plane, you might have to do Z, which is Z is also easy. You just select one of the sidelines. Anyways, so for the X and Y plane, so this is the X and Y axis. So we're always, I think it's easiest to, so basically on the machine, when you're looking down at the piece, if this is a top view of the CNC bed, this side right here is going to be the side all the way to the left and all the way to the end, like closest to you, closest to the opening. So that's usually how that's where I want to put my origin. And then from there, this direction right here is going to be positive Y, and this direction here is positive X. So this is where our origin wants to be, and we want Y direction here, X direction, and then Z coming up. So to do that, it's asking us to select the X axis. So this would be the X axis we want, and then the Y axis, and then I think this right here looks like it would be Y axis. Good. And you see the direction is wrong though. So this is the correct X direction, but the Y direction is wrong. So we just want to do flip Y axis, and now those are correct, and then Z is also correct. It has to be correct. And then we want to select the origin. So right now, we don't want to have to zero it in the middle because we don't know where the middle is of the stock, but we do know where the corner is. So we're going to zero it right at the corner right here. So, so now we have our directions, our axes, and then also we have selected it at we've set the origin. And then it will ask you for a model. If you don't select anything, we'll just select everything. Like right here, it says no model selected, all models will be used. If you don't want this to happen, you can select each one. It's not too big of a deal and it hardly matters. Okay, so now you want to move over to the next tab up here to stock. And in stock, you want to, it's going to always be on, actually, it doesn't have to always be on relative size box. But you want it to be fixed size box. So make sure it's fixed size box, and then you can create your own dimensions. So what I probably should have done a while ago, save this as user default, then it will always be fixed size box for me. So you want to be fixed size box. And one quick thing, sorry for interrupting here, but any features that you're unsure about, if you just hover over them, it will have a nice drop down menu and you can kind of read about it. Some things I've tried to read and I don't understand, but most things you'll be able to understand what they're saying. So we want a fixed size box and where we set our own dimensions. So we have a width and we want the width to be a little bit more, right? Our piece is probably going to be 6 inches and then our depth is probably going to be 8 inches. Oh, not 87, 8 inches. And then our height is 1/4 inch. So that's correct. And then this round up to the nearest is not important. You put the dimensions in. I don't know what that does. Set rounding increment to final stock size. Whatever. It doesn't matter if this is a super big value. Right, it doesn't actually affect it, so I don't know what that does. Anyways, and then based on this, right now all of our stuff is in the middle, but what if we want it to be, pretty close to the origin? We can actually set an offset. So let's say from the face of the stock, so right here I said X negative side. So this is the X negative side, this is the X positive side. So from the X negative side, I want to set an offset of, let's just say, an 1/8 inch, the diameter of the tool bit. So 0.125. Oh. Sorry, when you hit enter, it saves it. I didn't mean to do that. And then let's do that for the Y also. So the Y negative side and then just 0.125. Oh, too many. Okay, so that's all you have to do for setup. And now you have this stock right here. And this represents the piece of material you're actually going to be cutting out of. That's the yellow bit. And then you can see the other pieces inside. Okay. So now that you have the stock, whoa, did not mean to do that. Now that you have the stock, you can start making your toolpaths. So the toolpaths are what's going to actually cut the stock. So there's 3 main toolpaths you're going to use. There's going to be a 2D pocket, which is like any inside pocket. There's going to be 2D contour, which is going to be the outside or like some really big inside pieces. And then there's going to be drilling here, which is when you want to use a drill bit to just drill a bunch of holes of the same size or whatever. Make sure they're the same size holes. And then, okay, so I'm going to start with pockets, show you how to do a few things, and then we can go to the other ones. Also, some stuff transfers over, and some stuff is a little bit unique for each one. Okay. So I'm going to first go through this manually, how you'd first do it if you're just starting, and then I'll show you some little shortcuts later on, but just to make sure I don't skip anything that I've already have as a default, I'm going to just go through everything. So when you open this, you want to go to milling. You want to, we're using flat end mills. And then you want to go to, that has all these fusion libraries that have a bunch of bits, and then you want to go milling tools, inches, right here. And like I said a couple of times, we mainly use either a 1/8 inch end mill or a 4mm end mill. So I'm going to select the 1/8 inch one here. And you can select these presets, even though we're going to modify them a little bit. You can select aluminum roughing. So this is an aluminum piece, I should say. This is where aluminum and plastic pieces are different, where you have different speeds. So I'll talk a little about that. But so now we've selected our 1/8 inch flat end mill. And the first thing is coolant. Our machine doesn't actually control the coolant, so it doesn't matter what this is on. It doesn't matter if it says whatever. It doesn't matter. I'm just going to disable it, but it doesn't really matter. So now, because I've disabled it, it says custom, but that's fine. We run our end mills at a fast RPM. I've always do 18,000. So I'm just going to go through what we have done, what I've done over my years, what's worked for me. It doesn't mean you can't change this if you think it will work. If you're trying something new, that's fine. But this is just what we've got to work with the tools that we're using. Okay, so 18,000 RPM, and then this surface speed. You don't need to worry about surface speed. That's just based on, it's like the surface speed of the end mill, so it's based on the size of the end mill and then the RPM. It's going to tell you the surface speed, but don't need to change about that. The ramp feed rate, I've always kept it the same as the spindle speed, and that's fine. So ramp spindle speed should be the same. And then cutting feed rate, this is how fast the actual tool is moving through the material. So it kind of depends what bit you're using, but I think we mainly have started just using carbide bits. So with carbide bits, you can do 60 inches per minute. Pretty fast, pretty fun to watch. A little bit scary at some points, but pretty fun. Lead in, lead out. We don't use lead ins and lead outs, but just for consistency, I would just make them all the same. And then you'll see how you don't actually have to put all this information in every single time. So let's keep that the same. And then ramp feed rate, we can also do the same. The one thing that you shouldn't have the same is this plunge feed rate. That's if the bit's going all the way just down. You don't want to be going that fast. 20 is fine. Also for metal, you're never really going to be going that fast down because you really only ramp down. You don't do feed rate. So that's good. So this is how you want that page. And then the next page is going to be geometry, and this is how you actually select the geometry. So a really nice thing about making these components and doing the 2D geometry way is that you selecting geometry can be much faster, because this is like only 6 pieces. That's not that much, but sometimes you have so many pieces, and then imagine you have to select each hole that you want to do by itself, right? So that's not going to work. So the fastest way to do it is if you select this face contours, and then you do inner loops. And then you can just select each of these things, each face of the piece, and it will select all the inner contour, all the inner geometry of these pieces. So now it's selected all these pieces, all of these faces. So I'm going to do a quick, I'm going to delete that. We can do it again, but I'm going to show you just the other way to do it, because sometimes you have to do the other way, and that's totally fine. You just select the geometry, you'll select that one face, and then you can keep going. One thing that you should know is sometimes it will put this arrow on the outside and it will look like this. And basically what that means is the machine is going to cut all of the stock that you've laid out except for this inside bit. And that's not what we want. So just, if that happens, just click the arrow and it will move to the inside and you'll be all good. And it will only cut the inside, and that's what you want. Okay, so I'm going to go and just select all the geometry again. So yeah, I'm just clicking this button and then clicking the inner loops, and that's how I'm getting here. Okay, so now it's selected all these things. And some of these are holes that you could drill, and you probably should drill. And in this scenario, maybe you just want to select these 4 big pockets and drill everything else, and that's probably the best way to do it. I'm going to just go like this, and I think some of these actually are too small for the end mill to get into, so we can turn those into holes, and that would be fine. But I'm just trying to show you how the general way to do it. The rest of these things, don't worry about. They're fine. Okay, so now that we're at heights, and these are all these are the heights of the machine based off the stock, or they should be based off the stock. You want to base it off the stock, not the pieces. So basically, that's the reason the first time I put the 2 pieces on the same level. If they weren't the same level, we can reference the geometry fine and base it off the stock. But sometimes what happens is people forget to base off the stock, or the stock is a little bit messed up because when creating it, they got confused because the pieces are at different heights, and then you have these weird depths, and sometimes it will go all the way through. Basically, just make sure it's based off the stock. That's my big takeaway here. Clearance height, retract height, feed height, I've never needed to touch those. Those are fine. You can read about what they are, but don't need to worry about them. These are the 2 important heights. Top height, which should be stock top, based off the top, and then stock bottom. So I think it's normally selected contours. I think because I have set defaults that it wasn't, but make sure it's stock top, 0. You don't need an offset here on the stock bottom. And then we have a little offset to just make sure we cut all the way through the material. So this is about a 30-second, negative 0.03. That's below, so cut that much below. Maybe we get really level bed and we're not making a big mess, and we can actually reduce that so we don't cut into the wood as much, but it's fine to cut in the wood. Don't stress about it. So stock top, stock bottom. So that's all you have to do on this page. Just make sure it's based off the stock values. And now we have a bunch of other information. Let's just go through the stuff that's important here. Okay. Tolerance, size comment, those things don't really need to worry about. Maximum step over. So this is basically, let's just pull up, maybe I'll have a nice image with it. Yeah. So this is basically how much the tool bit is stepping in each time to remove the material, or stepping out. Usually actually moves out. But you can see here at the adaptive clearing, it's only like cutting half of the width, and then into the legacy 2D clearing, I don't know what that is, but it's like fully cutting in. So when you're cutting metal, you only want to cut like over you only want to cut half of basically the radius of the tool bit, right? So for maximum step over, I believe I do 0.08. So this is actually a little bit more. I'm not sure. Wait, 0.0. So let's just go with what's half the radius, and then I'll talk about it in the next one, because I have all of my defaults set for the thing I'll show you in a little bit. But basically, maximum step over should half of the radius, 0.0625. That's a 16th of an inch. Not half. Sorry, half the diameter, the radius, 0.0625. Okay, and then you also have multiple depths. This I know that I'm a little more aggressive. I think it's a similar rule. You want to just go down half the radius. Not again. Half the diameter, the radius. I don't know, I'm confusing myself. So this should be 0.0625, but you can really just do 0.08. I'm pretty sure it's working fine. I'm not exactly sure what that value I usually use, but I'll get back to that in a little bit. So finishing step downs. Great. Sorry. You don't need to worry about anything else. It's really just that value. I don't know why I was reading that. Okay, so finishing passes. And this is something that we're kind of, I think, still trying to figure out, still trying to do some tests, do some research on. Joe has been doing some, and I think he'll probably get back to us. And I don't know, whoever's watching this, but you should be able to ask somebody there that knows what we do. But how I've done it in the past is use a step over 0.001, which is a really small step over, and you just need to do one finishing pass is what I've done. We've had some that mostly works. So I guess first to say what finishing passes are, it's basically it will cut the geometry, and then it will do another pass just to make sure the geometry is the right dimensions, right? So this has worked fairly well for me, or for us. It's really the whole team. You don't want your people building stuff like these pieces don't fit together, the bearing doesn't fit in there, right? So you definitely need some finishing pass when you're doing bearing holes or other geometry that matters. If you're just like roughing something like some lightning holes that don't matter, then you don't need to do it. You save some time by turning it off. But when you're doing some geometry like a bearing hole, you want finishing passes on to this or whatever else the person tells you at that time. So this is what I usually do. And then this other option, stock to leave, make sure that's off. I've set my defaults to a really small value, so it doesn't matter. But many occasions I have, or other people have forgotten to turn it off. And then basically what it does is that it will leave that much material on the geometry. So if the stock to leave was 1/4 inch, it would leave a 1/4 inch uncut material. So all of our geometry is exact. Just turn it off and you don't have to worry about it. You should probably set your default to really small, so if you forget, it's not a big deal. Okay. Sorry it's taking so long, but hopefully by the end, You'll have so much information, you're going to forget it all and not know how to do anything. But then you'll slowly absorb it and it'll be all good. I don't know. That's negative. Sorry. Okay. Okay, linking. I've never really had to touch any of this. Sometimes if you set some value, sometimes it'll say like this value set to 0, that can't be 0. Safe distance, whatever. Lead in, lead out. I think they're default on, but turn them off. I wouldn't use them. And then for ramp, so the ramp, so basically for plastic, I've always just plunged and it's been fine. For metal, you're going to want to do this ramp type. It's helix. It just goes down a little more gently. The default angle is like 2 degrees, I think. 8 degrees has worked great. It's a little faster. Step down. So there's some things that actually matter here. So the ramp clearance height, this is how high it starts ramping. This default value is like 0.01, but it can take a while to actually get to the material, and it's just like cutting in the air. So I've made this a pretty, I think it's actually a little higher than that. 0.01, I don't know. Anyways, this is 0.005. It's fine. Even if it like touches a little before it thinks it does, it's really not going to matter. It shouldn't break the bit. So that's what I usually do. And then the other thing, the minimum ramp diameter is basically the diameter of the ramp. So I also make this value really small. It basically allows this bit, if an 1/8 inch bit, to get into like do these small holes if you need to. If you have a bigger value, it sometimes will create an error and actually won't go and cut these holes. And here, that's why you can't cut this. I mean, the bit just can't fit into these holes. So that's why. So if geometry doesn't show up, you can just make this value pretty small. I've never had a bit break from doing like a really tight helix, so I think that's fine. I mean, you should just drill these, so whatever. Okay, so that is basically all. If you want to, sometimes I've had to use exit positions, but it's a rare thing, and you can read the description and figure out how, if you need to do it. Okay, so I'm gonna hit OK, and hopefully this will all generate. Great, and it's even doing these holes. So maybe I'm going to change it because I want to show you also the holes. So I'm going to change this to be a bigger value. That's like a 1/16 of an inch. Hopefully. Okay, so it doesn't do them anymore, right? And it gives this little error, but the error doesn't stop you from uploading, so it's fine. So, okay, so that's pockets. I'm going to go back and actually make the pockets again. That seems repetitive. I'm just going to, it will be much quicker, and I'll show you a little bit of just how you can do this much more efficiently. So basically, what you have on the local computer, and it should be set up there mostly, is a lot like this. So we had the Fusion library. This is the local library for the computer. This is the one for my laptop, but there should be also one for the CNC computer. And basically you can have your own end bit. So this is the 4mm, that's a weird number, and then the 1/8 inch end mill. So here, because this was actually not a carbide bit before, these feed rates should actually be a little bit changed. I wonder if I can, let me see if I can edit it now. Yeah, we can edit it right here. I'm just gonna, does editing this affect it? I don't think it affects it. Oh yeah, that's all just the same. Ramp feed rate should also be higher, and that's fine. Everything else is correct, except. Okay, so I edited it on somebody has to edit it on the CNC computer, but this is from a personal computer. That's how you edit it, and then because we now have carbide bits, it's good. So basically when you select that, we've already selected all the settings, so we don't have to change any of that. That's all set. Then you can just go straight onto geometry, and let's just do this again quickly. How long? 44 minutes. Wow, it's gonna be a long video. I've learned a lot over the past 3 years. So I know this was it was like this before, also with stock top and stock bottom already selected, and this offset. But something that's nice is when you select this, preset because you're never changing anything. There's no little differences. When you set as save as user default, when it's in this configuration here, these user defaults will show up. Otherwise, sometimes you won't get you won't get the user default. So that's the reason. So once you have that set, then you can always just set the user defaults, and then they'll always be there. And then you have to do very minimal work on these pages. So maybe, yeah, so this looks like, so this is my user default, and that's the value I wasn't sure about. I did 0.08, but actually here we see that it's, I guess I have 0.063 for both of them. 0.08 should be fine. Yeah. This is a low, this is like what's recommended. Recommended. It's fine. Oh, that's funny. Okay. Finishing. So I don't have to go through this. This is all the same. Make sure to turn off. It's annoying you can't put that as user default to have stock to leave off, but turn off stock to leave. Okay. So that's all how we want it. And then this, sorry, I didn't think I mentioned before, this tab is new. I've never used it. Don't worry about it. We're just doing 3-axis. And then, yep, same defaults here. Great, and I'm going to make this value bigger again so we have the same result. Actually, it doesn't even matter. I'm going to hit OK. They're the exact same toolpath, so I'm just going to delete one of them. Okay, so that's the fast way to do is you use your local library, have all the presets that you want for the computer. So once you do this at your home, you also have to set up your own local library. It will take a little time, but it will pay off once you make whatever, hundreds of toolpaths. I don't know. You'll make a lot. Okay, so we've got pockets down. It's one of the 3, but there's a lot of similarities, so hopefully the rest go faster. So let's do a drill. The first thing I want to do is, let's see what this dimension is. I think it's 530 seconds. Radius, diameter, yeah, 0.158, that's 530 seconds. Or it's close enough. It's meant to be a 530 seconds hole. Sorry, not inspect again. So now we go to this drill. Basically, you're going to have to select your drill. So here we want to, it's in hole making, and then you can hit drill. And you can also, if you want, you can put this into the library. I've never put it into the library, but that's fine. Hole making tools, inches. If you want, I believe you can just, yeah, 5 divided 32. And that's just a quick way to search it. Pops up, aluminum. And I've just used the default they give you. That's worked fine for me. Selecting geometry, you can, so this is select same diameter is usually what I click, and then you just need to select one face as long as these are components. Select one, and then it'll select all of them the same diameter. Beautiful. Heights, same thing, whole top, whole bottom. I believe that's fine. Stock top, stock bottom, fine. Then negative 0.03, and then this drill through bottom is because you can see there's a tip, so you don't want the tip to hit the bottom. You want to actually drill all the way through the bottom. So there's no lip. So I've always selected that, and it's fine if it drills a little deep. You can probably figure out what the exact value you need is for the drill, but a little extra is not bad. And then this is just drill rapid out, whatever. That's fine. So that's a pretty easy toolpath to make. Drilling is pretty easy, and then you just select the right tool to put it in. Great. And so now we have both of the holes. You can see all that stuff's done. And now the last thing we're going to do is actually to cut them out. So that will be a contour. 2D contour. So here, oh, sorry. What I should say, let's do this. Just select the default again. Not this one, this one. If usually what you do is I usually do holes first, and then it will actually just keep the same bit as the last used one. So it would have been the 1/8 inch end mill, but because I did pockets first, it didn't do that. Anyways, this will keep the same presets as before. You have to select the geometry, but that's pretty easy. Again, make sure the arrow's on the outside, so it cuts on the outside of this line, not the inside, because you want the inside of the stock. But all those arrows look good. Heights should be default, good. Make sure it's not to leave. Okay. Also, I should just quickly mention. So multiple depths, because I'm not sure if I'm going to show any plastic parts. The maximum step down for plastic can be much higher. I usually do like 0.15, so you can just step down a lot more, which means if you're cutting like 1/8 inch plastic, you can just go all the way through and not have to worry about multiple depths. For aluminum, 1/8 inch, you should definitely still do multiple depths like this. Like I said, 0.08 is fine also. There's gonna be, when you're doing the contour, it's not like the pocket, because you wouldn't just have to cut all the way through. It's not like you can have a step over, so there's no step over, which is why you could maybe slow this down a little bit or whatever, but I've never had anything break. So, okay. That's one of the biggest lies I've ever said. I've never had anything break. Stuff breaks all the time. You try to always avoid stuff breaking, but it's not like, don't feel bad if stuff breaks, and it's just a chance to like figure out what went wrong, try to refine your technique. Sometimes just little silly accidents. I've broken so many tools. What I was trying to say is, I don't think that was the root cause of any of my problems, or any of the bits breaking. Okay. Linking, so this is all the same. Turn that off, and then ramp, you want on 8 degrees. Looks good. Yep. So now we have it all. So we've made these tool paths, and this will be ready to cut on the CNC. Okay. So let me just check. So we went through using the library, saving stuff as default. So all those values you should save as defaults. Being able to quickly select geometry for pockets. Dealing with the arrow. Okay. Yeah. So let's just finish this up. So something that you might want to do, you don't have to do, and it kind of depends. But if you're ever unsure about something, you want to see how it works, you can actually simulate, and it will pretend they're on the machine. It's just really weird speed dial. Like, it will go really slow or like really fast, but you can find this in between, and basically it will show the machine actually cutting it. And right now I'm just doing the contour, which is fine, but you can actually go through each thing and just make sure each process looks good. You can also move it around so it looks like it's cutting it out. We'll make it go faster. There we go. You see it does multiple depths. Looking good. And you can also see how close it gets. It's fine if these paths overlap, as long as this path, hopefully being able to see my mouse the whole time. As long as this path doesn't cut into the other piece, that's when we have a problem. Which actually, it won't actually cut into the other piece. It will just not actually cut through at that point. Once you do it, it will happen whatever sometime, and then you'll understand, but just make sure the pieces are far enough apart. So that looks good. And then you have to upload it to the machine. So to do that, you can just hit 2D Pocket, post process, and then you have to name it something. Okay, so I've always did a naming convention, like let's do street sweepers, and then if you do a slash, that actually makes street sweepers into a folder. And then I just do pockets. So I know this is the pockets and the street sweeper branch, and then I'll copy this and just copy and paste it into the other ones, and then change pockets to holes or pockets to contours, whatever. And that's how I usually like to do it. The units for this is going to be millimeters, because yeah, that's the unit that the CNC controller reads. So make sure that's millimeters, and then you're going to want to do CNC router parts. That's what you want to choose from. I don't know how hard it is to find. Let's see if we can find it. CNC router, I guess it's already, but in C's, you can find it. CNC Mach 3, that's the name of the thing we're going to do. Yeah, let me just talk about so the wood shop CNC. Let me just talk about that one a little bit. I believe that's the shop bot. Well, I know that's the shop bot. So let's go down to shop. A bunch of different ones here. I think there's 2 options if I remember correctly. Oh, yeah, ShopBot tools. I think it's a ShopBot Open SBP. That seems correct if I remember correctly. I don't know what this is. Maybe it's because it's not connected to the CNC or something. Copy post, no. Copy and post. Okay, I'm not sure what this is. Anyways, use the shopbot, and then the last thing would be for that machine that uses inches. So select inches here, and you see there sometimes stuff just pops up. I don't know what it is. I've never had to do. Oh, I didn't even know this tab existed. That's cool. Anyways, I was going to show you another way to do it. If you select multiple things, you can post them together. It doesn't make sense to post any of these together because it will just go back to back and the machine won't stop. And for these, you want to switch drill bits, and then between the pocket and drill to the contour, you actually want to put screws in the table to hold the pieces you just cut out in. So when the contour happens, they don't just go flying and break the bit or something. So you don't want to post any of these together, but it seems like this is another way to post them together. You can also select them and just together and then post them as one file, but that's kind of cool. Maybe it's a new feature, who knows. Anyways, you could just hit post. I'm not gonna post it, I don't need it, but that's how you do it. Okay, so that's the most general stuff for plastic. Well, that's it. You can do the same speeds and feeds. The main thing is you can just step down, be more aggressive with the step down. Yeah, I think that's about it for the main things. I'm gonna go into, so that's basically how to make a toolpath. I think I'm gonna go into a little more specifics for doing the 3D geometry, which you probably should at least watch one time, and then also tubes, which is another major thing. And then maybe I'll have another video, if this video is getting kind of long, of some just tips and tricks for running the actual CNC. Okay, so let's go back to our 2D geometry piece here. And I'm going to show you how you want to do these different, just make these different 2D geometries. So go to manufacture, and we're just going to create another quick setup. This piece has a nice geometry for selecting the axes, so let's just do that. The X, Y, box point, easy, flip X, it's all set up, right? And it's I already selected, great. And then this box, fixed size box, is now my new default. Amazing. I can't believe I haven't done that yet before. We'll just go with it. That seems fine. Okay. So, yeah, so we have both of these 2.5D geometries facing up, right? That's important. So let's go, and I'm not going to worry about the contour and stuff because I've already shown you how to do that, but I'm going to just show you you can do these 2.5D geometries. Okay, so to do them, we're going to want to do a pocket for that. We'll select the bit from our library. Perfecto. And now we select the geometry. So these are pretty easy geometry to select. Oh look, arrow on the outside. Sometimes you like select 500 holes and they'll all be on the outside. You have to click that and then click the arrows. It's a pain, but you know what? So I'm just going to show you. I think maybe this works on these pieces. Yeah, look at that. That also works there. Okay. I know that when you do drill holes, sometimes the select same diameter doesn't work though. But looks like the faces work. I know, I just like doing the DXF, extruding it, all this the same color, whatnot. But there is some real advantages, so don't just take it for the color. Okay, so you see when I try to select something like this, like that's not gonna have like that's not a pocket that I can make, right? So this is going to come to some of the difficulties, and I'm going to show you just how to do that in a little bit. But for now, I'm just going to unselect this. I don't even know how I selected. Oh, whoops. I'm going to see. Because I think you can select at any level. It doesn't matter. But like if I select this, it just, I'll select this, and then I'll show you what it's going to do, and then what you should actually do. Anyways, okay. So this is where it gets where you need to be a little bit different, unique, I don't know. This is where you have to change stuff. So you can base it off the stock top or stock bottom, but basically the bottom height of where you want to cut, that's what you want to change. So let's say from the stock top, we just want to go half the depth, which is going to be 1/8 of an inch. If the piece is 1/4 inch, you should check whatever depth it is. It doesn't have to be 1/8 of an inch. It could be 1/16 inch, 3/16, whatever. But I think both of these are 1/8 inch, and it doesn't really matter for these pieces because we're never going to cut them. So if I do stock top and then I do negative, it's going to go down that much, and that makes sure from the top it goes down that much. Perfect. So that's how you do the 2.5D depths. Everything else should be whatever basic things are. I'll turn this off. Just make sure this is fine. Sure, we'll put on multiple depths. Why not? Just be official. Okay, that all looks good. I select this, and we'll see. These all generate well. And when you not at an angle, it kind of looks weird. But let's see. Oh, I just selected. Now you can see where they're actually cutting in. Oh, sorry. So those cut those in, not all the way down. That's perfect. But you see here, that's not getting all the geometry we really want because it's not going to the corners because it thinks it can't go through the corners because that's the geometry selected. So the best way that I've come up with getting around that is actually if you go back to design, we're going to create a sketch geometry that we can select instead. And that sketch will just be the whole circle. So if we just select this, that will be at the face of our sketch. We just make a circle. Hopefully have at least a little CAD experience so this doesn't feel totally foreign. So basically, it's very simple. So if you, whatever. Now we're just going to constrain the circle. So the first thing is we want it to be concentric with this other circle here. Great. And then we want it to be equal. So we want these two to be the same thing. So now we have a circle of the exact radius that we need, and then we can go back to manufacture. And when we make this pocket, instead of we'll select this circle instead, it'll get the inside, and then we'll actually just cut that out. And that doesn't matter because it will cut out all this thing, and then when we get the contour, let me actually get off this piece. Get the contour will come in here, and then the pocket's perfect, the contour is good, and then you don't have to worry about like trying to take a file. I mean, don't waste your time. It's not worth it. Do this quick little thing. And that's the other thing. You can always have sketches if you need to make different edits. Probably not the easiest thing to do, but it's not terrible. Okay, so one last thing for Fusion 360 before maybe I've covered everything. Well, I'll end the video so you won't have to hear anymore. But maybe I'll be regretting something that I'm like, oh no, I didn't tell them that. If you don't click the one button, the CNC won't explode. Okay. I feel like this is really awkward, but you know what? I'm kind of just talking to myself now. Boom, dun, dun, dun. Okay. Sorry. So I'm going to show you a tube. I'm just going to select one of these tubes quickly. Beautiful tube by Zale. We'll be happy that I'll take one of them. Anyways, let's say I'll take an 1/8" tube. This is a fun one over here, you know. I'm just in assembly. You can just export from assembly. So for tubes, it's fine if you don't have to do it. It'd be really annoying to have to do a 2D. You need to do a 3D. It's a very three-dimensional object, so make sure you do edges or step or whatever. But I think edges. I think step's more for SolidWorks, but I think it probably would work fine for Fusion 260, though. Don't quote me on that. Okay. So let's upload it. Maybe I should have just done that one. We already have some. Whatever. We'll just go through the whole process. Doesn't harm anybody. Patiently waiting. I'll put some music in the background. It's not actually music. I just found this like magnet, and if I swing it, it makes this cool sound. So maybe you can hear it. Okay, I love that sound. Anyways, it loads perfect. Oh, where is it? It's all the way at the top, probably. Second stage 2. Great. Open it up. Don't have to worry about anything in design. Go straight to manufacture. Default inches. That's so weird. I've tried to fix that for so long, and if it just started working now, that's crazy. Maybe it knows I'm leaving, so I was like, now's the time to work for him. Okay, so some quick things I'm going to say about the tube, and we can get to it. Get in touch. You're making it is you're going to have to actually do multiple setups because each side is a different setup. And when you do pre-drill tube or punch tubes, whatever, you don't actually have to drill these holes as long as there's no unique pattern. Like you don't have to make a setup for this side, right? It's only the side you're actually going to be cutting. So it'll be this side, and you might think, oh, it's the same, it's mirror geometry or whatever. I probably can just run the same path. It's actually because when we set it up here, right, our first origin is going to be right here. And let's just find some geometry you can base that off of. Okay, it's going from the top left to the bottom right, right? This arc. So if you just ran that for the other side, so let's just flip it. So we'll flip the tube like that, right? And now this is our corner. Look, it's now going from the bottom left to the top right. So if you do that, this piece would actually be messed up because not everything is mirrored. Some pieces would be they would be structurally fine, but they would just look funny because these crosses would be crossing each other. And if you go look at Radium, if Radium's still around whenever you're watching this, Radium the Roomba, best robot. Though I'm a 2022 guy, and 2023 was a fun game, but 2024, coolest robot we built, definitely. Love it. Yeah, you'll see some crosses because there was some little confusion, little mistake. It's fine. It worked perfectly fine. But yes, you do have to make two separate setups. Okay, so to make the setup, let's jump in. So selecting the X and Y should be pretty easy for a tube. And flip both of them. Box point here. Great. That's easy. And then now, make sure it's fixed size box, definitely. This should be 1 inch. I don't know. I must have set it for default or something, weirdly. Oh, 1 inch. And then I hit, I saved it again. Whoops. Anyways, you want to make sure it's just, you don't want any extra stock. It's just the stock that you're going to cut. 1 inch by 2 inch by whatever length it is. This time is 21.5. Right? That's as much as you want to do. Okay? So basically, I think when I'll talk about how to run the CNC, I'll talk about how you zero on tubes and how you set stuff up, and it's a whole process, kind of frustrating. Definitely, if somebody wants to, they can try to test some things out, see what works best, try to improve that process. I never really got around to getting that far, but we got a system that worked. But this is how you set it up in Fusion 360, and there's let me see. There's one other thing I would say is that when you're selecting, let's just pull up a pocket quickly. I can just make this. I'm turning myself all around. Let's just select stuff. But basically, the depth is the other thing. You don't want to cut all the way through the piece. You just want to cut. Just cut through the first layer, right? This is gonna be 1/8 inch, and you can go a little extra. And it's fine if you even go even a little more than a little extra, but don't go all the way through. Don't, because you're gonna end up running the machine into the piece. It's not gonna be pretty. So let's just do this for the whole thing. I don't know if it's actually gonna get all the geometry you need, but it doesn't matter because I'm not actually cutting it. That's your problem when you have to cut pieces. So here's when you would sit stock top, and then you go down the negative 0.15. That's 0.3 or 0.025 more than you need, and it will be totally fine. Great. Here, yeah, stock to leave, turn it off, multiple depths. Yeah, you need it for this. Whatever. That looks good. We'll see how much this actually cuts. Oh, seems like it might have actually cut everything. Yeah, look, a pretty easy way to select geometry. Nice. Anyways, you probably want to actually drill these holes, not machine it. It'll be much faster. But that's how you do tubes. That, I think, wraps everything up. Hopefully, you didn't get too lost, and you can start making some parts, having fun. CNC's fun, powerful, really cool machine. I enjoyed it a lot, so hopefully you all do also. Well, I might see you in the next video about Mach 3 and running the CNC. But thank you for sticking with me for that 1 hour and 10 minutes. But now you know how to make a toolpath. Bye-bye.